Good morning. Here's the tangent function. Now, since we began, I've mentioned the tangent function in our class notes, but we've never really done any on the packets. So today we're going to talk about tangent. Tangent, again, if we're just on a regular triangle, it comes from the side opposite to the side adjacent. It is the angle here that is connected to the adjacent side and the hypotenuse, but it doesn't use the hypotenuse in its ratio. It only uses the opposite and the adjacent. And that is because tangent comes from sine divided by cosine, which we've mentioned plenty of times before. So if we take a look at this first problem, exercise 1, for the right triangle below, state the sine, cosine, and tangent. Well, they gave us the base and they gave us the hypotenuse, but they did not give us the altitude. So notice that Pythagorean theorem is very, very strongly connected to trigonometry. You can't do trigonometry without knowing that Pythagorean theorem. So if we again have our a squared plus b squared equals c squared, we are now going to have a squared plus 4 squared equals 5 squared. So now we have a squared plus 16 equals 25. A squared equals 9, square root, and a equals 3. So now my altitude is 3. Again, once I know the sides of my triangle, I know everything. I know my sine is 3 over 5. I know my cosine is now 4 over 5. And the tangent is 3 over 4. So you should be getting really good at the Pythagorean theorem and these ratios by now. And so once you know your original 3 functions, you know the other functions, because the reciprocals are a flip. So now sine goes to cosecant, and this would be 5 over 3. And the cosine goes to secant, which would be 5 over 4. And now the cotangent becomes 4 over 3. So you know one, you know all 6. Next, you have this triangle. This triangle, here's the right angle, making 2 the hypotenuse, and making the adjacent side 1. So I don't know the opposite side again. However, you have a 1 to 2 ratio, and you might have picked up already that a 1 to 2 ratio means that this guy up here is 30 degrees and this must be 60 degrees, just because of this 1 to 2 ratio with the side and the hypotenuse. So that would make this guy rad 3. Don't believe me? Let's do the Pythagorean theorem and prove it. Rad 3 squared plus 1 squared, will that make 2 squared? So this would be 3 plus 1 equals 4, and it works. So when you notice different things that we've been talking about for the last 2 weeks, go for it. You're probably right. So this here, they gave me a 30-60 special right triangle. And I know that this side is 1, so this would have to be where the 30 degrees is, and I know theta is 60. Now, they didn't ask us for that, but I just picked up on it because it's the exact same thing we've been doing. So this brings us back now. If theta is 60, all of these are now going to be the sine is 60, and the cosine is 60, and the tangent is 60. And so rad 3 over 2, if you memorized that chart because you used it so much, cosine is now 1/2, and your tangent is rad 3 over 1, or rad 3. So then, once you have this, you have your reciprocals. So if I now have my cosecant, which, flip this over, is 2 over rad 3, got to rationalize. We cannot have a radical in the bottom. So that then rationalizes to 2 rad 3 over 3. Cosine flips to secant, and that gives me 2 over 1, which is 2. Tangent, the cotangent will now flip and be 1 over rad 3. Got to rationalize again, so that would be rad 3 over 3. So notice the beginning of this packet is nothing more than what we've already been doing. Now let's consider the unit circle, and we're never ever getting rid of the unit circle. It's just the biggest part of trigonometry. Pythagorean theorem, unit circle. That's why I spend so much time on the unit circle, and hopefully you are comfortable with the unit circle by now. If you're not, you really do have to contact me. I cannot answer questions that you don't ask. All right, consider the unit circle below. Answer the following questions based on the diagram. If xy represents a point on the circle, how can we define the tangent? Well, we're on the unit circle. Key word. So x is cosine and y is sine. So tangent is now y divided by x, because tangent, going back up here, is sine divided by cosine. Never going to change. And again, on the unit circle, sine is the y-coordinate, cosine is the x-coordinate, y over x. Given how we define sine and cosine, how can we define tangent in terms of sine and cosine? Well, again, asking me up here for this, and this is because tangent is sine divided by cosine. So a lot of review right now on this first page. So now they're saying use the unit circle. Okay, so now they're giving us the different angles. So we have the unit circle, and again, if I draw myself a unit circle, remember at 0 degrees and 360, this first point is 1, 0. At 90, this point here is 0, 1. At 180, this point is negative 1, 0. And at 270, we're at 0, negative 1. So there's my unit circle. And those are my quadrantal angles, all the angles that are on the quadrants. So 60 degrees is quadrant 1. Quadrant 1 angles are all positive. That also brings me back to my notes where I write out my quadrants, all students take calculus. All are positive. Sine and cosecant are positive. Tangent, cotangent are positive. Cosine, cosecant are positive. So quadrant 1, 60 degrees. The tangent is 60 degrees. Well, if I'm on a circle and I draw out my 60 degrees, remember this is 30, and opposite 30 is a 1. Hypotenuse is 2, rad 3, just from the other page. Oops, sorry, move that. And so the tangent now is rad 3 over 1. And it's positive. And these are exact. So when they ask you to do this, they give you one of these special angles and they give you the unit circle, you have to give exact. You cannot type it in and give a decimal from the calculator. They will not accept it, and that's so, so important to know. All right, so now the tangent of 45. Well, again, quadrant 1, everybody's positive. And in quadrant 1, if I draw a 45-degree angle, that's 1, 1, rad 2 from our special triangles and from those charts. And the tangent of 45 is 1 over 1. So it's positive 1. Let's go to the tangent of 150. Well, now this is when we are in quadrant 2. Here's my 150-degree rotation. I'm in quadrant 2. And if I reference the x-axis, the 180, my reference angle is now 30 degrees. So this is, again, a little bit of review. And in quadrant 2, sine and cosecant are positive. That means tangent is going to be negative. So this is now equal to the negative tangent of 30 degrees. And again, negative because quadrant 2 is sine's quadrant. The x-coordinate would be negative. The x means cosine. So if sine divided by cosine in quadrant 2 would give me a negative tangent. They all tie together. So the tangent of 30, opposite of 30 is 1 to 2 on the hypotenuse. This is rad 3. The tangent of 30 is 1 over rad 3. And the negative does not leave us. And we rationalize this, negative rad 3 over 3. Again, please, 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 you cannot just type in the tangent of 150 on your calculator and give me that decimal. I cannot accept it. You have to draw this out and do this work. Lastly, the tangent of 180. Well, the tangent of 180 is right here on the unit circle. And the tangent comes from sine divided by cosine. So if I come over here and I say, all right, the tangent of 180, the sine is 0 and the cosine is negative 1 from the coordinates, y divided by x, this gives me 0. So the tangent of 180 is 0. These numbers are exact. Now, consider the angle theta is 90 or pi over 2. Well, there we are back on the unit circle. Like, we are never getting rid of this unit circle. All right, so the sine of 90 is the y-coordinate 1. Cosine of 90 is the x-coordinate 0. So now the tangent, why would it be undefined? Well, it would be undefined because tangent again, sine divided by cosine, 1 divided by 0, can't divide by 0, makes this undefined. And that, again, you guys should be so tired of hearing me say these same things, and hopefully that's the case. And you're following along, and you're getting to the point where you're rolling your eyes at this video, and then that means you actually know it, and that would be the best thing ever. So now, at which of the following angles is tangent undefined? Well, tangent's going to be undefined whether you're at 90 or at 270, because this is where cosine is negative, and you can't divide, this is where cosine is 0, and you can't divide by 0. So whether you're 90 or 180, 270, tangent is going to be undefined. So determine the value of the cosine. So undefined now would be choice 2, 270. Sorry, I went too fast there. Apologize. So now, here it is. Just like the ones that you were doing in the unit circle packet since day 2. The sine is 5 over 13. The terminal ray lies in the second quadrant. So, for a lot of people, when I wrote you guys notes saying you gotta write it out, here's your graph. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. X, y, negative x, negative y. You guys have been drawing graphs since elementary school. There's your graph. I'm in quadrant 2. Here's my angle in quadrant 2. Now if I make a full triangle, they're telling me the sine is equal to 5/13, opposite over hypotenuse. It all goes back to my ratios. Well, how big is the base? Again, Pythagorean theorem, a squared plus b squared equals c squared. So my altitude is 5. I don't know my base yet, and my hypotenuse is 13. So now I have 25 plus the base squared is equal to 169. when I subtract 25, I get that the base squared is 144, and square root, my base is 12. Now guys, this is where we pay attention. I came 12 in the negative direction. My cosine goes with x. Therefore, cosine is going to be negative, and if cosine's negative, tangent's negative. My sine goes with y. Y is positive. So in quadrant 2 again, that is why it is sine's quadrant. Sine and cosecant are positive. So now let's find the value of our functions from this picture. We now have the sine again. I'm just going to rewrite it. The sine of theta was 5/13. That was given to me. So that now gives me cosecant theta of 13/5. So if you can have a fraction, you can flip it. I have all the faith in you. Now I have the cosine of theta adjacent to the hypotenuse, 12/13. Then the secant would be 13/12. Tangent opposite to the adjacent, 5/12. And then the cotangent would be the 12/5. But I'm not done. I have to consider where I landed. And again, the 12 went in the negative direction. If there's a 12 in my ratio, I'm negative. Positive, positive. 12 makes me negative. There's a 12, makes me negative. Negative and negative. Once I leave quadrant 1, 2 functions will be positive and the other 4 negative. Sine positive, tangent positive, cosine positive. And that is your class notes. That was a review. Again, another day of pulling all of this together. I hope this helped you out. I thought maybe if I worked right on the packet, it would be a little bit more clear. Please, please let me know how you're feeling about this. If there's anything you need help on, say, I need help on lesson 3, day 2, page 9, whatever. Tell me. I can't help you without you asking, and I really want to help you out. I hope you're all well. I miss you all. I really, really wish we were in school together. Bye-bye.